Let's talk about powering your RV. Alright, so today I'm here under the front of my fifth wheel. Got the front bay open, exposing all the glorious goodness that is the core of the RV power system in our RV. Now, in a previous video, I recorded and showed how to what I think is the best way to attach solar panels onto the roof of your RV. If you haven't seen that video, I definitely recommend you watch that. This is kind of a continuation of that, where I talk about the actual core components of the RV power. Now, there's another video I've got posted. If you haven't watched it, it's called Powering Your RV, the Paradigm Shift. If you haven't watched that video, I definitely recommend you watch it as well, because it kind of covers the paradigm that I used when designing the power system for our current rig. So without going into any more detail on that, let's jump in and look at these different components. So to start, let's look at the foundation of the power system, which is the battery bank. So I have got lithium batteries, a bunch of Lion Energy, so they're Lion Energy Safari UT 1300 lithium ion batteries. I have 8 of these. These batteries, these are awesome. By the way, I love these batteries. I'm actually going to be doing another video talking specifically about these batteries, so I'm not going to go a lot of the details here. But some basic features or specs about these batteries is each of these batteries is a 105 amp hour rated battery for 12 volt with 1344 watt hours of power. Now these 8 batteries I actually have wired together in a 24 volt system. I did that so that I could keep the amps down, because when you have 12 volt systems and you have lots of components, your amperage is going to go high. So I wanted to do something with 24 volt system to bring it down. The amp wise makes it easier and scales a little bit, I think. Anyway, that's another discussion for another day as well, the details around that. But back to the batteries here. So because they are a 24 volt system, I have them wired essentially into 2 strings of 12 volts. So I have these 4 batteries that are a 12 volt string, and then I have those 4 batteries that are a 12 volt string, and then I have these 2 strings connected in series, which gives me 24 volts. Because of that, I have the 105 amp hours that are rated each battery. I have to divide that number by in half, because I'm doubling the voltage. So in a 12 volt bank, this would be 840 amp hours of power. Again, it's a 24 volt, so I have to cut that number in half. So in 24 volt, it's 420 amp hours. This is why, by the way, I like to use watt hours instead of amp hours, because watt hours, it doesn't matter what voltage and amperage you're using, the number is always going to be the same. So the watt hours number for this battery bank is 10,752 watt hours. So quite a bit of power I have available here. Now, I know people are going to ask, how heavy is this? That's another one of the things I really like about Lion Energy batteries, is they are, I think, the lightest, if not some of the lightest. I think they might be the lightest lithium ion batteries available on the market. Each of these cells is just a tad over 23 pounds. So you put them all together, and that gives me a total battery bank weight of about 185 pounds. That's super light for the amount of power that this thing produces. So 10,000 plus watt hours of power at about 185 pounds. So that's the battery bank. Love these batteries. Again, I'll be doing another video on those, going in a little bit more detail. All right, so coming from the batteries, let's look at the next thing, which is the battery monitor. So I'm using the Victron Energy BMV 712 battery monitor. As you can tell, the blue in here, I'm a big fan of Victron. We'll talk more about that here in a few minutes. But I really like these battery monitors, and I like the 712 version of these because they have the built-in Bluetooth. The nice thing about that is you can pull up the mobile app on your phone, and it'll connect right to the Bluetooth in this case, the battery monitors right here at the top. You can see I have a number of other devices showing up as well. So the Smart Solar MPPT charge controller I have up there, that has built-in Bluetooth, so it's going to show up here as well. That's this line here. And then I've got a Bluetooth dongle over here connected to the multi-pluses that allows me to get Bluetooth connectivity and get some information about those, do some basic control, and then we'll talk about this Raspberry Pi here in just a little bit. So that's the battery monitor. That's kind of the you know, why I like the 712 version, because it gives me the Bluetooth with all the rest of the things. The battery monitor is connected to this device right here. This is a shunt. The idea is you come directly out of your negative side of your batteries into this shunt, and then the battery monitor connects to that. What that does is that gives you a very true and accurate measurement of the usage of power coming out of the system, because it's the first thing that's out of the negative, so it captures basically all power that's going through the system, through the shunt, and therefore the battery monitor. From that, I come up into this Lynx Distributor. So the Lynx Distributor is the main power distribution unit for the rig. Now, in previous solar installs that I've done in trailers, I've used just these, you know, basic bus bars as the power distribution. When I started doing the design for this, a company that I work with that is amazing support, and also, you know, great. I mean, they got skills, they've got experience, they've got awesome products you can purchase from them. Sounds like I'm doing a commercial for them. I'm not. They're just a really good company to work with. That's Continuous Resources. Matt at Continuous Resources, when I was talking to him, he suggested that I go with a Lynx Distributor as the main distribution unit, as opposed to going with these bus bars, because, well, these bus bars turn out to not be able to support as high of amps as they say they're rated for, so there's some potential issues there. But it's not just that, it's also because this Lynx Distributor is actually just awesome. It's a really nice way to go. So let me go ahead and take the cover off here, and we can look at the guts of this system. All right, so if you look at this, it's basically two bus bars. It is a bus bar based system. So I've got my negative bus bar down here on the bottom that runs underneath behind stuff, and then I've got my positive bus bar there on the top. And if you'll notice, my connections for all the devices, though, connect down here on this bottom connection side. And what you do is you bridge from the main bus bar to the main connection with a fuse on each one of your devices. That's one of the also big advantages of this Lynx system, is that every single one of your devices that run off of that power distribution system can be fused. It's a lot easier to troubleshoot, a lot easier and cheaper to install, because you have individual fuses for the devices rather than one big honking fuse that sits in between, like your inverters and your distribution system, where if it blows, everything goes down. This gives you that granularity, which is really nice. And those fuses, they're easier to install, they're cheaper. It's just a better way to go all the way around. Another cool thing about that is if you need more connections than just those four there, you can take multiples of these and you can connect them together. As a matter of fact, if you look over here on this side, you've got those bolts. The idea is you can take another one of these Lynx panels and just take in the bus bar connections here and plug it into the side and connect them on there, so you can actually extend that out and have a larger distribution system if you have more devices that you need. So really awesome piece of kit there. And it was not that expensive, to be honest. When you factor in the cost of the fuses and all the extra bus bars that I need had I gone this direction, this was really not that much more expensive to go this route. So I'm really glad that I went that route. Thanks, Matt, for the suggestion on that. So that's the power distribution, where everything else comes into. Coming out of the positive side of the battery bank, I take it right through my main kill switch. So this kill switch, if I were to power that off, it's going to kill all power coming from the battery bank to the rest of the rig. So that's my main kill switch for power for the rig. But that's not the only kill switch. I actually have a number of other points in which I can kill power to different parts of the system. So the rig, when it originally came from the factory, that was its power distribution unit over there, that little kind of bus bar fuse system. It came out of the battery bank that was right here, so it was just a single battery, and plugged into that. And then from that, you go out to all the rest of your 12-volt DC connections in the rig. Now the main kill switch that comes off of that goes to the rest of the components in the rig is actually on the other side of the wall in the pass-through compartment from this inverter. So it's just right over on the other side. So I can still use that as a kill switch if I want, but it only kills the 12 volt components that it was basically designed in by the factory. There, I actually have another thing that allows me to kill even more, basically all of the 12 volt connections, and that's this. Well, it's a combination of a couple things. So first of all, before I talk about that kill switch, let me talk about a piece of kit that you need to be able to go from a 24 volt system to the main 12 volt system in your rig, and that's this component right here. This is an Orion 12 volt or 24 volt to 12 volt DC to DC converter. It takes the 24 volt coming from the battery bank and it steps it down to the 12 volt that you need for inside of your rig. And it can deliver plenty of amps, which is nice. So you don't have to worry about that as well. So what I did here is, coming from the distribution, I actually run it through a breaker box. And this set of breakers right here is an 80 amp breaker that comes from the 24 volt distribution through that breaker into the 24 volt to 12 volt step down. If I trip that breaker right there, it powers off all 12 volt to the system. Kind of like the one behind that was built in the kill switch, but those, interestingly enough, don't kill all power. There are still a few things that bypass that kill switch in your rig. That allows me to kill all 12 volt power to my rig, but still maintain 24 volt for inverter chargers, for the batteries, for the solar charge controller. So that's another point that I have to be able to kill power for just that set of components. The other two breakers here are in there for the charge controller. So let me talk about the charge controller really quick before I talk about those. So the charge controller, it's a smart solar MPPT 100/50, so it's 100 volt, 50 amp support. So it can deliver 50 amps and it can support 100 volts coming in. That'll run either 12 or 24 volts. It's running 24 volts in my system, and the nice thing about that is when you run those 24 volts, they support more power coming in from the panels. So that one right there supports, I think, 1400 watts of power in 24 volt. If it's running only 12 volt, it only supports 700 watts of power. So that was another reason I chose to go 24 volt. It allows me to maximize the power coming out of my solar array with going with a less expensive, shall we say. It's not cheap, it's still a kind of a pricey controller, but I would have to go even much more expensive to be able to support the higher solar powers that I wanted, the number of panels on my roof with a 12 volt system. So 24 volt gave me that benefit as well. So anyway, coming into the charge controller, I have the panels. Now, thank you, Grand Design. Grand Design, starting, I think, 2019, 2020 model years, they started pre-wiring solar to the roof on all of their models, reflection on up. And so this is a 2020 model Grand Design 268BH, reflection 150 268BH. It came with that pre-wired, which is really nice because I didn't have to run those wires. The idea though is the wires come from that into here through this 30 amp breaker before they go into the solar charge controller. So that means if I trip that breaker right there, I can cut off power coming from the solar panels into the system, but all the rest of the stuff still works. I also have a breaker next to it. This is a 60 amp breaker that is from the charge controller back into the power distribution system. So if I trip that breaker, I can kill all power coming from the solar charger into the system, but I can still maintain power coming into the charger if I wanted to. So I've got that as an option for killing power to isolate a different part of the rig. So again, you can see I have a number of different options for isolating power from different part of the systems. All right, so let's look at what we've talked about, see if there's anything else I need to cover. Okay, yeah, we need to cover the inverters. We talked about the battery monitor, we talked about power distribution system, we talked about the solar charge controller, the breaker box, we've talked about the Orion. Now let's talk about these bad boys. These are Victron Multi-Plus 24 3070. They're 24 volt, 3000 volt amp inverter chargers. They can deliver 70 amps of charging per inverter, and they support up to 50 amps of AC power pass through to the AC system. These these are awesome. These are some of my favorite inverter chargers on the market. Now, why do I have two is a question you're probably going to be asking. The reason I have two is because this is a 50 amp rig. It has a 50 amp service coming into it, which basically means I have two legs of 50 amp coming in on 50 amp service. I have, in the United States, we have what's called split phase, where you have one 50 amp, 120 or 110, 120 volt leg coming in, and then you have a second 110, 120 volt leg coming in 180 degree out of phase. That allows you to, if you just pull off of each of those individual legs, you've got two legs of 110 volt power, but you can also bridge those two legs and get a 220, 240 volt system. We're not using this for 240, it's only 110, 120 volt system. So what I basically do is have two 110 legs coming in. If I want to power my entire RV with an inverter, then I need to have both of those legs serviced by an inverter, because each of these only supports a single 50 amp leg coming in. So this is the one that's connected to my first leg, my L1 coming in from my 50 amp service, and this one is the second one coming in from the second leg. So together they're providing 50 amps of power for the entire rig, which means I can run everything in my rig without a problem. It's really nice, especially with having 10,000 plus watt hours of power here to support it. One thing to note, one of the design goals of this system was portability and modularity. Now, I talk about that in the video about the solar install, what the best way to attach solar to your roof, and that was one of the big key concepts, is being able to change some things up on the solar install with the panels, be able to take those panels off when we sell this rig and be able to move them to another rig. That portability was a big design goal, because this power system is a significant monetary investment. It is probably, the system alone is about between a third and a half, again, the cost of what the entire rig was. I mean, it's not cheap, but it's something that I've invested in a way that I can then take it with me, so that when we trade this rig in and trade up to our next rig, I'll be able to take all of these components out and put into the new rig. So batteries can come out very easy. These inverters, you just unscrew them off of the back and you can take them out. You can take all those components out, and there were only two wiring changes that I needed to make to the stock rig to support this, and both of those are very easily undoable. So the first one of those we mentioned is that connection there between the Orion and the original battery system. So that basically plugs in as if it were the original battery. When I plug that out, I just put an original battery back in, take the connections from there, plug them down to the battery. 12 volt system is powered like it was before. The other wiring thing that I had to do was the AC wiring into these inverter chargers. Now, one thing about these inverter chargers that you need to understand is this is kind of covered in that the paradigm shift video. These really become the core power providing components for the rig, both AC and DC, which means the AC power from shore needs to come from the shore directly into these, and then from these into the breaker panel in the rig. That's different than from the factory. From the factory, your shore power goes directly into that breaker panel. But because these become your main power source, you actually have to rewire that so it comes from the shore into these, from these into your breaker panel. Now, the modularity aspect comes from this, in that I can take these out. All I have to do is butt connect those connectors in a little junction box right there, and then it's wired essentially the same way as it was from the factory, with the added benefit of the person who buys this rig from me already has this stuff pre-wired. And if they want to put their own inverter system in, all they do is they drop one of their inverters in here, pull those wires out of the breaker box, plug them into their inverter, and now their inverter is in line before the breaker box. So modularity, that was one of the big design goals with this. So let me review the components again, make sure I've got everything covered that I wanted to. So we've got the batteries, we talked about the battery monitor, the distribution, the solar, the breaker, the Orion. We've talked about the inverters. There's actually one last thing I do want to talk about, and that's this little guy right here. One of the things I really like about Victron components is, well, first of all, their individual components are really quality, they're good components. And once you start combining together with, you have the Bluetooth dongles that make them really easy to connect to. So those are cool things. But what it really makes it cool, where you really start to see the synergistic effect, is when you add a GX device into the mix. Now a GX device is basically a little computer that all of these devices plug into, and it allows you to do visualization of what's going on and control and management of the whole system, and it just really brings everything all together. Now they make a number of different GX devices. Probably the most common one you're going to see is the Color Control GX, or CCGX, and that's a little about 4-inch panel. It's a little computer that's got a little 4-inch panel on it, and it shows you basically everything that's going on. Those are cool. However, they have a new version of the GX device out called a Turbo GX that is basically a standalone computer, and then that panel, it's a little 5-inch touchscreen panel, is separate. And you can move that panel wherever you need and just wire it back to the main GX device. That's brand new. It's on order. I don't have all of the bits here yet, and so I'm waiting for that to get here, and once it gets here I'm going to install it in the system, and I'm planning on doing a little tabletop review of it and kind of an box opening video too as well. In the meantime, however, while I'm waiting for that to get here, I'm using this right here. This is a Raspberry Pi running the open source version of that GX software. And so it's kind of like a Color Control GX, just with a bigger screen, because I've got the standard Raspberry Pi 7-inch or whatever it is screen on there. But this is essentially what a Color Control GX is. It's like this, but it's just got a little bit smaller screen. This is awesome. I have not installed it inside because I'm going to be using that touchscreen, the GX Touch 50 component of this. That's what's going to be installed permanently in the rig, or permanently in a way that I can take it out for modularity purposes, for portability. But this is functioning as that GX device in my rig right now, and I'm just leaving it up here in the front until I get the Turbo GX installed. These are cool. I'm just saying that if you have Victron devices, this is what actually makes everything worth spending kind of that extra money that you spend on Victron components. They are quality components. They do cost a lot, but it's the GX device that really brings everything together. So I'm super excited to get that Turbo GX and the GX Touch 50 and get those installed. But in the meantime, this is what I'm using. Now, one of the other cool things about this is, because it's a little computer, it's got built-in Wi-Fi, and I can actually connect to this on my phone, and I can see that screen right there on my phone. So let me bring this up and I can show you what I'm talking about here. Right here. So you go to that screen, you tip it sideways, and you'll see the same thing here that I'm seeing on my phone is the same thing that I'm seeing here. So you get that remote control aspect of it as well, and it plugs into their online service, which is called VRM, and if it's got internet connectivity, it can send all of its information back up to the internet, and you can actually check historical data here as well on a web page. Now, one of the things you can see, that blue line there dropping off really quickly. I've actually been running a battery endurance test on this the past couple of days to see what I can actually do with this 10,000 plus watt hours worth of power. Just to kind of give you a quick overview of what I've been able to do. This thing has been running for over 48 hours, completely disconnected from the shore, and I am running, I have the electric water heater turned on, I have the refrigerator running on electricity instead of gas. I've just been using stuff in the rig like I would if I were out, so turning on lights and just, you know, turning off lights, just kind of letting it sit. This thing has gone for over 48 hours without any input other than just a little bit of solar that's been coming in, and we've had some cloudy days, so it really hasn't been generating a tremendous amount of solar. This has been going on for over 48 hours, and I'm now down to 20% left in the battery bank. So that's just one of my initial tests of this system to kind of see how it's running. Actually doing pretty well, I think. I'm probably going to be adding a couple more panels on the roof to see if I can increase the solar coming into it, see if I can get a little bit more out of that. But that's kind of an overview of kind of what this thing is able to do based on my initial tests. So just kind of wrapping things up, this is the core of the power system for my RV. This is kind of my dream system, to be honest. This is what I've really been working towards through the past few installs that I've been doing. And now that I've got it, it's modular. I can take it with me so that when we do our next rig, all of this stuff is going to come with me into the next rig. Unless, of course, the person who wants to buy this rig wants to pay the extra value, and then I'll upgrade, but probably not going to happen just because how expensive these things are. So I got my dream system, super excited, and I'm really excited to put this thing to work as we go out and hit the road. All right, well, that kind of sums up this video. Hopefully you found this video interesting. Hopefully you guys found some stuff in here that might be able to improve your installs, give you some ideas for your installs. If you have any questions, go ahead and post those in the comments. I'll try to get to those. If you have any comments, let me know what you think. Post those down there as well. And as always, like and subscribe. You know, liking and videos and subscribing to our channels definitely helps us as YouTube creators and content creators to provide stuff that the audience likes and gives us kind of a bump in ratings as well. So we appreciate that. And again, if you have any questions, go ahead and post them down below. You can also get us on our Facebook page, the Travel New Trails on Facebook, and Twitter as well. Until next time, enjoy the road, find some experiences, and get out there.